Hello there, Narek is here. Today I'm going to solve the third exercise from the first session of 2018 chemistry, which is related to electrochemistry. So let's start. Electrochemical cells. Metals differ by their tendencies to lose electrons. A metal M1 is more active than another metal M2 if it has a greater tendency to lose electrons. The metal M1 serves as anode in an electrochemical cell M1, M2. Document 1 represents the schemas of two electrochemical cells G1 and G2 during their functioning and the voltage U of each one. So let's check document 1. In document 1 we have the first cell G1 is formed by zinc strip and magnesium strip, and we have the voltage 1.61 volts. Now, of course, zinc is immersed in Zn2 plus solution, so solution containing Zn2 plus ions. As for Mg strip, it is immersed in a solution containing Mg2 plus. As for the second cell G2, we have a cell formed by Mg and Cu. It is formed by magnesium and copper. The voltage is 2.721 volts, so it's greater than the first one. So there is a difference between the voltages, the voltage value. So each metal has a tendency to lose electrons more than the other. That's the idea that they were already talking about. In the second cell, they have also mentioned that in the salt bridge you have your ions which are migrating towards some parts. So NO3 minus is migrating towards Mg2 plus, the solution containing Mg2 plus, and K plus towards the solution containing Cu2 plus. So that could be an indication in order to find out about this cell. Let's start by the questions. By referring to document 1, answer the following questions. Knowing that magnesium strip is the anode of cell G1, indicate the direction of the flow of electrons in this cell. Very simple. In this case, you have Mg, which is the anode. So it is losing electrons much more easily. So the electrons will travel from magnesium. They will travel from magnesium towards the strip of zinc, so they will have this direction from the anode towards the cathode. Write the half reaction of it that takes place at the anode of the galvanic cell G1. So we have at the anode we have oxidation equation, will be Mg being transformed to Mg2 plus 2 electrons, so it's losing 2 electrons. The half reaction that takes place at the cathode of the cell G1 is Zn2 plus 2 electrons, which gives you Zn. So in this case, I'm going to write down the half equation of reduction, Zn2 plus 2 electrons, it gives you Zn. In order to find out, the question will be, of course, deduce the overall equation of the reaction that takes place in the electrochemical cell G1. The overall reaction will be Mg plus Zn2 plus. It gives you Mg2 plus Zn. So this is how you can actually find out the overall reaction. Since you have 2 electrons on the right side and 2 electrons on the left side, so you can simply cancel them out. Show that magnesium strip is the anode of the cell G2. Now, why would the magnesium strip be the anode? The only indication that we previously mentioned, it was the migration of the ions from the salt bridge. We have NO3 minus migrating towards the solution containing Mg2 plus. So what does it mean? It means that Mg2 plus is increasing in concentration, so the number of positive charges are increasing. I need negative charges in order to have a certain equilibrium. So NO3 minus is migrating towards the part where Mg2 plus is increasing. How could Mg2 plus increase? It's through the oxidation of Mg. So Mg is going through an oxidation in order to be transformed into Mg2 plus. So Mg is the anode. This is how you justify that Mg is the anode of the cell G2. You have to check the direction where towards which direction the ions from the salt bridge are migrating. Choose from the proposed representation the one that corresponds to the electrochemical cell G2. Now, the first one, in order to represent, you need to put the anode on the left side, the cathode on the right side. So Cu with Cu2 plus, you need to forget about it because Cu is on the left side. This is also on the left side. So C, Mg2 plus salt bridge, of course, that's the one which is right. I do not write Mg2 plus Mg because I have the oxidation. Mg is being transformed to Mg2 plus and Cu2 plus towards Cu. So it's the C, the answer is C, which is the right one. In an electrochemical cell, the greater the difference in the tendency of metals to lose electrons, the higher is the voltage of the cell. Arrange the metals Cu, Mg, Zn on an axis by increasing order of their tendencies to lose electrons. So we have the tendency to lose electrons. We know that the higher voltage is 2.71, which is between Mg and Cu. So Mg and Cu are quite distant. So I need to write down Mg and Cu distant. As for Zn and Mg, they are close because the voltage is less than 2.71, is 1.61. This is how you're going to be able to represent them on your axis regarding their tendencies to lose electrons. That's all for this exercise, which was number 3 from session 1 2018. I'm going to ask you to subscribe to my channel because I'll be uploading new materials. I'm going to solve new other sessions. I can also share with you my Instagram and Facebook account. You can write me directly or you can simply leave a comment. That's all for this time and see you later.